So the last thing to really talk about now that we've discussed all these different techniques for collecting packets is really when do you use each technique. And I have a flow chart that's going to walk through some of that. I'll go through that in a minute. But before we get there, I do want to describe a few tenets or tent poles, if you will, of packet collection. Just some things to keep in mind, really some best practices that go along with that. Your mileage may vary with some of these. It's going to be highly situational, but throughout my career, these are a couple things that I think stand out and are worthy of being aware of when you think about how to capture packets and where to do that at. Number one is to get as close to the problem source as possible. So if you, this speaks to our conversation of routers and being downstream of a router on the appropriate subnet. If you have a device on your network that you need to capture packets from and you need to intercept that communication, then you want to be on the same network segment of the device, usually downstream in the same broadcast domain on the same network segment. Now, sometimes you may actually want to be physically on that device. You may want to have the packet sniffer installed locally, and there's certainly a lot of cases where that makes sense and some that it doesn't. But really, if you have a problem, getting as close to the source as possible is what you want to do. Now, sometimes that won't be the most convenient. Sometimes you're in headquarters and that's in a branch office. Maybe you can leverage some type of remote capture capability or remoting into a local machine and then capturing from that or something of that nature. But again, getting as close to the problem source is going to ensure that you're seeing the packets you need, you're seeing the addresses you need as well. That's very important. Next is you want to be minimally invasive as possible, and this is really mostly appropriate for the security aspect. If you're examining a machine that you think might be infected, then you might want to be careful about installing a packet sniffer on it and interacting with that machine. It could cause some adverse effects. Maybe you have to enter a password along the way and there's a bad guy on there and they're able to see that password. Maybe it tips an attacker off that you know that they're operating on that system, and that can be bad as well. So you want to be minimally invasive, and for that matter, you also want to limit the excess packets you might be generating. So the use of certain features within a packet capture may generate additional packets, and we'll talk about that more when we talk about name resolution. So if you're capturing packets and you're trying to do name resolution at the same time, that might generate some unwanted DNS traffic that you have to deal with. And for that matter, the act of downloading or installing a packet capture tool directly on a system generates traffic as well. So you want to be careful about generating traffic when your goal is really to passively assess traffic. And that kind of relates to the next point, which is to limit contamination of packet captures. Packet data is quite verbose. It's a lot of data, and often it's a lot more data than you need. Most of the time, you're going to be looking at 0.01% of your packet capture to get the answers you need. You're not going to be looking at all the excess data. That's why filtering is so important with packet captures. You have to be able to take a packet capture and filter it down to get to the stuff you need. We'll talk about filtering more later, but if you start right from the outset thinking about exactly what you need, you have to do a lot less filtering because you're only capturing the things you need and not getting all that excess. So when I talk about contamination, I'm talking about making sure you're collecting the exact things you need in the exact right areas. So if you only need to examine the communication for one host, don't capture off of a span port that's looking at an entire network segment. Limit that down. If you can do that by, ARP cache poisoning or port mirroring, maybe that's one way to do that, and we certainly talked about that. Or maybe you're doing some type of capture filter as well, which we'll talk about a little bit later. Next, be aware of routing devices, and we kind of hit on this already. If you're upstream of a routing device, you're going to have trouble seeing the true IP addresses of the devices that are downstream if something like NAT is in use, and that's something you have to be cognizant of, or else you're going to have a real hard time pinpointing the right traffic and understanding the communication in the right way. Last but not least is use enterprise hardware for enterprise use cases. And I mentioned this when we went through all the different types of packet capture techniques. There are switches for home networks and there are switches for enterprise networks. The ones for enterprise networks are a lot more likely to have the capability to do span and mirror ports that you'll need. For that matter, when we're talking about taps, if you need to use a tap on a 10 gig link, you're not going to want to use a really crappy non-aggregated tap you paid a couple $100s for. You're probably going to be investing a few $1,000s or tens of thousands of dollars to get a really high quality tap that has all the features you need, can keep up with the throughput, can have the failover capabilities, and maybe some caching as well. So packet capture for the most part can be very cheap in isolated use cases, but if you're doing it in a really broad use case like an NSM scenario where you're capturing for the entire network or a network segment, you need to use enterprise hardware to support that. And unfortunately, that gets expensive, but that's kind of one of those things where you have to pay to play. So these are the 5 tenets of packet capture that I want you to keep in mind when you're thinking about where to capture packets from, what techniques to use. So to kind of sum up a lot of the decision making that goes into how to capture packets and what technique to use, I've created this flow chart, which I'm going to provide to you in PDF form as well, so you can take it and print it out and laminate it or do whatever you want to do with it. Now, this isn't meant to be necessarily all-inclusive of every scenario, but generally just based upon best practices and general guidelines from what I've seen and observed in all the different packets analysis scenarios I've been in and those of colleagues and others. Now, this is really broken into 2 sections, so let's go through both of these sections kind of independently, just keeping in mind that your mileage may vary a little bit. Now, the first decision block we get to is really all about your environment, and it's really about whether you're doing this at home or in a really small office, small network environment, or you're doing it in an enterprise, really anything beyond just a few systems at that point. So let's start with the home part, because I think a lot of us are probably starting at home at least and maybe doing some experimentation, and that's probably the place most of you will end up right off the bat if you're just starting anew. Now, first of all, I start with the question, does your switch support port mirroring? I do this because generally that's the easiest way to go about this. This is independent of just installing a packet capture solution onto the machine directly. You'll see that solution is not mentioned here because that's kind of, we kind of all understand what that means and what that doesn't mean. So the first question, does your switch support port mirroring? And if it does, that's the easiest way to go about this. You'll see in the example I showed earlier that I was able to set up port mirroring in about a minute. It was just a matter of going to the right page on the web interface for my switch, clicking a couple things, and then all of a sudden things were working. Of course, there was a physical aspect of that. I had to plug things into the right ports. But that's easy enough in most cases. You're not going to have a hard time getting to your switch in your house, hopefully. So that's the easiest in that regard. That's why it's listed first. And it's also fairly reliable at any of the throughput levels you're going to be experiencing within your home. It's not like we're talking about a high throughput situation here. Now, that said, if your switch doesn't support mirroring, the question I would ask is, do you have a tap? If you do have a tap, that's another piece of hardware you would have had to have purchased or acquired somehow. And if you do have that, then that's another good option. I've listed as the second option because it requires actually, unplugging things and putting the tap in line, and that might be a little more cumbersome. And if you, purchasing a tap also requires, spending those dollars. So that may not be the right move for everyone, but if you have a tap, that's a good way to go next. And then third is, are you comfortable ARP cache poisoning? So if you don't have port mirroring, you don't have a tap, then ARP cache poisoning is the next thing to do. And I list, are you comfortable ARP cache poisoning? Because certainly you can do ARP cache poisoning no matter what, but you want to make sure you're comfortable with the technique and you're comfortable with the results. If you want to make sure you're doing this on a system that isn't going to break. For instance, if you have some type of maybe like Internet of Things device or some type of, your blender that has an IP address and you want to, capture the traffic of it, maybe it's doing some type of SSL or some type of other special communication where an ARP cache poisoning might break that communication. That might be a case where you're not comfortable ARP cache poisoning. So if that's not a concern, go for it. That's pretty easy to do. But if not, then you may have to look for another solution. And unfortunately, in this case, out of the 4 techniques we talked about, the only other solution is to hub out, which requires having a hub. And again, that's not really what I would recommend. So hopefully it doesn't get to that point. But you'll see on the home side of this diagram, really it's all about ease and convenience. So we start with port mirroring, the easiest, a tap, a little less accessible, ARP cache poisoning, which is maybe a little less desirable. So we've got that in the third rung, and then finally hubbing out. So we're doing it in order of kind of difficulty and accessibility in that way. Now, for an environment that's an enterprise environment, that's going to have a few different configurations, a few different things to talk about. First and foremost, we want to talk about whether you're talking about continuous monitoring or high throughput. So in these cases, that's going to be a lot of times like a network security monitoring scenario where you're capturing traffic 24/7, maybe for a very busy or large network link that has a lot going on. So maybe a gig link, a 10 gig link, something bigger. That's what we're talking about. We're talking about a continuous monitor, high throughput scenario. In these cases, you are pretty much exclusively going to want to use a tap. I don't recommend ever really using a port mirror for this, especially in terms of high throughput, because it's not really what it's designed for, and you can experience a drop of packets and all those other reasons we talked about when we talked about limitations of port mirroring. So if you're doing continuous monitor, high throughput, you should use a tap. You should definitely invest in the tap. You get what you pay for. So that's why we start here, because that's when you would want to use a tap. Now, if you're not doing continuous monitor high throughput, we ask a similar question to one we asked earlier. Does your switch support port mirroring? If it's an isolated scenario where you're talking about an individual host and it's not a high throughput thing, then port mirroring is great. And chances are, if you're in an enterprise environment, your switches do support that. Most of them nowadays do. So if you have that, that's the easiest way to go about this, and it works great. If you do not have the capability of doing port mirroring, the next question we're going to ask is, can the host be taken offline temporarily? If it can, then you're going to want to use a tap potentially if you have access to one, and you see that there at the bottom. If you can unplug it and put a tap in line, that's a great way to capture packets in a reliable manner that's not going to break anything, since it's actually a physical interception point for the traffic. But if you don't have a tap that you can use, or if that matter, if you can't take the host offline temporarily, then ARP cache poisoning is potentially going to be an option that will work for you. Again, we want to be careful to make sure ARP cache poison isn't going to break anything, and in a realistic scenario, you might not know that until you actually try it. But the good thing about ARP cache poisoning is it's not really going to interrupt the host too abruptly. If there's some live connections, they may break just for a temporary moment, but nothing like unplugging it from the switch and then plugging it back in. It's going to be a little less invasive than that. So you'll see when we're talking about an enterprise environment, it's really more focused on use cases and what's acceptable from a business perspective. We start with that continuous monitoring and high throughput use case, and if that's not applicable, we're talking about, do you have a switch? Because that's a good catch-all and one of the easiest ways to do this. And if not, we're talking about what's acceptable for the host you're dealing with. Obviously, it's going to be a little bit different if you're talking about an individual user's workstation versus your main company file server. That's going to change things a little bit. So again, this is your mileage may vary with this flowchart, but it is a good place to start, a good place a good thing to use as a general guideline. I think once you start doing this more and more often, it'll come second nature to you, and you'll just kind of know. You'll get that gut feeling. You'll know exactly what the right technique is. Now, that said, we're going to go through a lot of examples later on in the course where the practical scenarios. We're presenting a problem, and then we're going to work through that. And when we do that, I'm actually going to describe what capture scenario I'm using for this example, what might be applicable, and why that decision was made. So we'll get to kind of live through this diagram a little bit as we go through the rest of the course. That's going to bring us to the end of this lecture, all about tapping into the wire and collecting packets. So let's summarize what we learned. First of all, before you can analyze packets, you actually have to collect them. In a lot of cases, like in this course, I'll be providing you with packet capture files that have been already captured elsewhere. And interacting with those is fairly easy. It's just a matter of opening the file. But at some point when you want to attack your own scenarios, whether that's for general troubleshooting or network latency issues or security reasons, you're going to have to capture packets yourself, which is why this lesson is so important and so important to teach early on, so you can capture your own packets and apply the lessons you're learning on your network, whether your home or your work network. Packet collection, for the most part, is dictated by how networking gear operates. So we're talking about hubs and switches and routers, more recently, of course, switches and routers specifically, and how they create these natural visibility windows that can both help and hurt you depending upon your perspective and what you're trying to collect. So we talk about visibility windows and broadcast domains, upstream and downstream routing in terms of network address translation and things like that. So those are all important concerns when you're capturing packets. Now, to that end, I talked about 4 primary capture methods you can use to collect packets. Those were span ports, network taps, hubbing out, and ARP cache poisoning. And we talked about each of those. I did a couple demos. We talked a little bit about pros and cons of those things. Now, the decision for how you capture packets is an important part of the process, and for that reason, I talked about a couple of tenets or best practices of packet capture, and I introduced a flowchart you can use to help make that decision along the way. Again, as we go through practical examples in this course, as we do those, I'll talk about how you might have collected the packets that I'm providing to you. Some of those will be more real because they're actual real-world collected packets. Some of them are for a lab, and I'll talk about how I collected those in the lab and how you might collect them if it were a real-world scenario. But hopefully this gives you a good primer on the importance and the nuance of capturing packets, as well as some insight into the different strategies you can use for tapping into the wire.